Alright, day 2 of multiplying monomials. Let's look at and let's review our rules for how to multiply monomials. So when I am multiplying, I have the same base. All I'm doing is I'm adding my exponents. So here I've got the base of a. I'm going to take 2 and 3. I add them and I get a to the 5th. If I have coefficients in front, again, I'm still multiplying. So I've got 4 times a negative 3. Okay, let me expand this out. So I've got 4x squared, so 4x times x. And that's multiplied by negative 3, x to the 4th. So that would be x times itself 4 times. So here I've got 4 times negative 3. It's going to give me a negative 12. I've got x, that's x squared, x to the 4th. So 1, 2, 3, 4, 5, 6, x to the 6th power. Expanded out, this would be 5w squared, so 5w times y, and 6w cubed. 6w times itself 3 times. Okay, well 5 times 6 is 30. I have w, so 1, 2, 3, 4, 5, w to the 5th, and then I've got y. So again, all we're doing is we're adding our exponents. We're adding our exponents of the like base. 2 to the 3rd times 3 squared. Okay, well 2 to the 3rd is going to give me 8. 3 squared is going to give me 9. 9 times 8 is 72. What general rule can you determine from the pattern when multiplying monomials? So a review of yesterday, when the base variables are the same, then we are going to add the exponents. When multiplying, what do we do with the coefficients? We still multiply. Still multiply. All right, now let's look at the distribution property. Right? I've got a times a plus b. Okay, well I've got to take this a and distribute it to both terms inside that parentheses. Same thing if this was a cubed. If it was raised to a power, we would need to distribute it to both terms in that parentheses. So we would have a cubed times a squared, and we would have a cubed times ab. So plus, now we're distributing it to the second term, so a cubed times ab. Okay, now we can simplify this. So a cubed a squared, that's 3 and 2, that gives me a to the 5th. I've got I've got a cubed a to the 1st, so that's a to the 4th b. Now, can I combine these? Absolutely not. Those are not like terms. They do not have the same base. This is ab, this is a. Those are not like terms. All right, let's look at this one. Again, we're going to distribute here. So I've got 4a cubed times 1/2. So 4a cubed times 1/2 a squared. Minus, now let's distribute it to the second term. 4a cubed times 2ab. All right, now let's see if we can reduce. 4 times 1/2, so 4 divided by 2 is going to give me a 2. A cubed, a squared, those are the same base, a, so we can add our exponents. 3 and 2 gives me a to the 5th. Over here we've got minus, 4 times 2 is 8. A to the 4th, because 3 and 1 is a to the 4th, b. So there's my answer. All right, let's look at some example problems. Number 1, again, we're going to distribute. 3 times 7 is 21x plus 15. Easy breezy. Here, we're going to distribute. 3b times 3b is 9b squared. 3b times 8 is going to give me 24b. Those are not like terms. That's b squared, that's b to the 1st. All right, let's go down to number 5. Again, we're going to distribute. So I've got negative 2x times x, negative 2x squared. We're going to add our exponents. 1 and 1 is 2. Distribute here. We've got negative 2x times negative 5 is going to give me a positive 10x. Again, those are not like terms. Let's go to some problems on the back. What about number 9? I've got a trinomial. So I've got this number out in front times a trinomial. No big deal. I'm still going to distribute to every term inside the parentheses. So now we'll do it 3 times. So I've got a negative AB, so negative 1 in this case. I'm going to multiply my coefficients. So 3 times negative 1 is a negative 3. A to the first, B times B squared. So A, B to the first, and B squared is going to give me B to the third. Distribute here. Negative 1 times 3 is a negative 3. A to the first gives me A squared. B to the first gives me B squared. And we need to distribute to our last term. So negative times negative 6 is a positive 6. A squared and A gives me A to the third, B. Now, are any of these like terms? Do they have the same variable raised to the same power? This is A to the first, B to the third. This is A squared, B squared. This is A to the third, B to the first. So none of those are like terms, so you cannot combine anything. All right, let's go to number 10. Same thing, we're going to distribute. 4 times 9 is 36. M squared is going to give me M to the fourth, N, plus 4 times 1 is 4. M squared times M to the first is M cubed, N. Distribute to your last term. 4 times negative 2 is a negative 8. M squared, N squared. Look for like terms. There are no like terms, so we're done. All right, let's go to number 12. Number 12, let's distribute here. So I've got 3x times 4x. 3 times 4 is 12. X times x is x squared. Distribute here. 3 times negative 2 is a negative 6, x. Same thing, distribute this negative 6 to both terms. So negative 6 times 2 is a negative 12, x squared. Negative 6 times 3x is a negative 18, x. Now let's look for like terms. These are all subtracted, I guess you'd say, together. So I've got 12x squared and I've got a negative 12x squared. Well, 12 minus 12 gives me nothing, so those cancel out. Here I've got a negative 18x and a negative 6x. I'm going to combine those and I get a negative 24x to the first power. Again, when you are combining, you do not change the exponent, only when you are multiplying. All right, let's go to number 13. Number 13, we got a word problem. It says find the area of a rectangle with a length of 8x cubed and a width of 3x minus 5. Now the area is equal to the length times the width. So all I'm asking you to do is take 8x cubed and multiply it by 3x minus 5. So just like we did up here, I'm going to take this 8x cubed and distribute it to both terms. So 8 times 3 is 24. X to the third, x to the first, x to the fourth power. We're multiplying to the second term, so 8 times negative 5 is a negative 40, x cubed, no more, so x cubed. Easy breezy.